Well, if you take everything that we're familiar with, your body, the air, the buildings, the planets, the stars, all of that is made of atoms, and all of the atomic matter is only 5% of the universe. So I want to know, what's the other 95%? We call it dark matter and dark energy. Most of our galaxy is made, well, almost entirely of dark matter. So if we look at our galaxy, there's a flat plane in the middle where all the stars are. They're along spiral arms, but it's a thin, flat plane compared to this giant spherical region, which is full of some additional kind of mass. And you know it's there because you can see it gravitationally pulling on things. So we're very certain that it's there, but we want to know, what is it?
So currently, there's a lot of evidence from cosmology about the existence of dark matter and its amount as a fraction of the energy density of the universe. But particle physicists currently have not found the dark matter candidate in a laboratory experiment. So that is the current state, and there are many different candidates for the dark matter particle, and many, many different types of experiments you can build. So cosmologists are on one hand trying to pin down the phenomenological properties of dark matter, and experimentalists are trying to detect it in the lab.
On the theoretical side, we think we have some really good candidates.
The axion. I'm actually involved in a new idea to measure the axion in the lab. So that is my favorite candidate.
There are some particles called WIMPs. This stands for weakly interacting massive particles. So if that's true, these are particles that, well, they don't have electromagnetic forces and they don't have strong forces. So there would be billions going through you every second, but you would never notice. But we think they might have the fourth of the fundamental forces, and that's called the weak force. Now, if that's true, and here's where my work comes in actually, we realize that you should be able to build detectors. They're just sitting there underneath the Earth, actually. And then these dark matter particles come along and strike your detector, and you should be able to observe the small amount of energy that they deposit inside the detectors. So we had ideas for this about 25 years ago, and since then experimentalists have built detectors all over the world. Some of them are seeing hints of detection. They're seeing something that's unexplained. But then some of them are not. So you've got this conundrum. How can you reconcile positive results with negative results? And honestly, we're a little bit lost. So now we're back to the theoretical side, trying to reconcile these things. So it's possible it's already been discovered, but it's also possible that we're just going completely the wrong direction and we have to start over. So we'll see.